Hello, my name is Fernando de la Guardia. I work at BITSS and I'm here thanks to TIER. Very excited to talk to you about how to teach computational reproducibility in the classroom. Before we start, let me just tell you a little bit about who we are at BITSS. We are an initiative that works to improve the credibility of science by advancing transparency, reproducibility, rigor, and ethics in research and policy analysis. We're part of a larger center called the Center for Effective and Global Action. The core team that has been working at ACRE, it's this list of great people here. But at BITSS also there has been many others working in other projects, and we want to acknowledge them. So for the talk today, I will describe, the goal is to describe some resources that we have developed to facilitate teaching computational reproducibility in the classroom. So for that, I will just start with a motivation for why is this important. Then I will go over the framework of how do we approach computational reproducibility in this project. And then I will demo the tools that we have developed. So if in a TIER symposium, this might be a little bit redundant, but I think it's important just in case you have not been following this literature. There are some problems regarding replicability and reproducibility in the social sciences. By replicability, we understand basically using the same method over a comparable sample and obtaining similar results, qualitatively similar results. By reproducibility, we understand using the same data and same methods and code, hopefully, and obtaining exactly the same results. So for replication in the social sciences, there's a famous study by Nosek and co-authors, by Kammer and co-authors, Nosek and Kammer and Klein, and the replicability rates at most have reached 60%, at least have reached 30%. But for our purposes, the most important motivation here is on the right-hand side, that in terms of computational reproducibility, again, the exercise of using the same data, same code, and hoping to get exactly the same results, the rates are alarmingly low in the sense that we should be aiming for something like 100% in an ideal world. So the second motivation is this idea, and this is almost like a mandatory quote when talking about computational reproducibility. But with a slightly different angle, is the idea that when we talk about a scholarly output, we should not only be talking about the paper, and this is where the Clairvaux principle comes in, where we should move away from thinking of the article on itself and think of the article mainly as advertisement, and think that the actual scholarship is the entire software development environment and the complete set of instructions to generate the tables and figures. This principle is usually discussed when talking about the benefits of pedagogy and the benefits of incremental generator of knowledge. One dimension where it's under discussed and we want to highlight it is that this idea of a larger output of scholarship can have potential positive effects on diversity, equity, and inclusion, in the sense that in order to access the materials, in order to access the data, the code, you do not need to be in the right university, you do not need to have the right connections, you do not need to have the right language. This idea that you need to be polite enough or have the appropriate politeness to craft the right email that will get you eventually some data or some code, it's an important barrier. We think that increasing computational reproducibility can help us think that it might have some positive effects on DEI. The third motivation is this idea that we want to prevent the loss of knowledge. Every semester, graduate students around the world take empirical or applied labor economics or demography or biostatistics or any type of empirical course An atypical assignment will consist of reproducing the results of a paper and possibly testing the results of the robustness of those results. And a typical exercise will go like this. So first, the student or the reproducer will scope the paper, will see if there's data and code for any given paper. That itself, it's generating some type of knowledge. So the student is identifying that there is or there's not data or code. Then they are going to assess the degree of reproducibility for a specific paper or for a specific part of the paper. Again, knowledge has been generated in the sense that an external observer is assessing the degree of computational reproducibility of a paper or a specific component of it. Then it's not rare that somebody will improve it slightly. They might fix a path, they might automate the installation of some libraries, add some missing files, go find the original raw data sets and things like that. And finally, they will test if the results are robust to additional specifications that are not mentioned in the original paper. All these steps generate new knowledge. All these steps are somewhat lost by the end of the semester when the exercise ends. At best, you're gonna find it in a report of a end of semester report or a presentation. There are problems with this in the sense that the language, when we do these exercises, is not standardized. We have not yet adopt or decided if we want to talk about reproductions or replications when talking about this type of exercise. And also the current attempt, there are some current attempts to record this type of exercises, but are closer to a full paper. And this generation of knowledge does not always fit the format of a paper, but every time there is some type of generation of knowledge that could be standardized, and that's what we're gonna propose. Basically, as a result of this, each new semesters, new students have to repeat exactly the same efforts, reinvent the wheel. They do not take advantage of previous advances of previous students in other courses around the world. And there's a lot of opportunity also in building on top of previous exercise, and also there's a lot of opportunity in terms of aggregating all these assessments that students and reproducers are doing around the world. So that's the motivation for us to start thinking about how can we standardize this, how can we build a platform at the end of the day that will allow for reproducers to go through this exercise. So for that, we start thinking about our initiative, which is about accelerating computational reproducibility, and this is the framework that we have in mind. So first of all, a little bit of context. In 2006, the American Economic Association created its first data policy, and the policy back then was if you want to publish in any of the, I think it was then 6 journals of the EAA, you should publish some data, and there were waivers available. In 2019, there was a major update to that policy, and now for now what are now I think 9 journals, the requirement is that if you want to publish, you must post all the data and code, and the publication is conditional on verifying reproducibility. And if the data is confidential, they must document extensively how to access the data. There's also a new requirement to post all cleaning code, regardless, even if you cannot post the confidential data, you have to publish the cleaning code. And this effort have been led by Lars Vilhuber as a data editor at the American Economic Association. There's also a similar effort at the AGPS, American Association for Political Science. This means that we should expect high levels of computational reproducibility after 2019, but not before. We should not demand 100% reproducibility before, but we should aim to identify those gaps and try to improve them. So that's the mentality that we're trying to approach computational reproducibility. And also we want to move away from binary judgments. In this space, it is the reproductions can easily gravitate towards adversarial exchanges, in the sense that early career researchers have incentives to emphasize unsuccessful reproductions. Original authors have a more senior position also that they can use to deter in-depth reproductions of early career researchers. And also the media has a focus on eye-catching results like X% of research does not reproduce. We don't want to categorize papers as reproducible or irreproducible. We do want to say that a paper has a result Y in paper X has a high or low level of reproducibility according to several reproduction attempts. Moreover, there have been improvements to the original reproduction package, increasing its reproducibility level. That's how we're thinking about this initiative. And how do we approach this is that we're going to think of each reproduction attempt as centered around claims, not centered on the entire paper. Each paper might have one or more scientific claims or major findings which are supported by display items, tables, figures, or inline results. And each of these on itself has a set of specifications that support that main result. So we're going to ask reproducers to identify this path, to identify what's their target claim, what's the display item that is supporting this claim, and how and which are the specifications that are core to the reproduction exercise. A large part of this exercise is basically about standardization. As I said, there's a lot of discussion around these issues, but we need to, at least for the purpose of this platform, we need to basically commit to certain concepts, and these are just some examples of the things that we have to make explicit. For example, we have computational reproduction or reproduction referring to same data, same code, getting the same results, and replication as same method, comparable sample, different results. I will not say the word replication ever again. There's other things like a reproduction package, what is raw data, what is analysis data. There's also, it's important, we think, to distinguish between a paper that has no reproduction materials and cannot be reviewed any further, and how to move from that candidate paper into a declared paper, and other things that basically we need to standardize in some way. And then what we suggest is that reproducers approach this exercise in 5 stages. At the beginning, they have to select a paper, and this exercise, the exercise is basically either your instructor assigns you a paper or you choose a paper, but before you move on, you need to verify if there's any type of reproduction package, materials like code and data to reproduce. If there's nothing, that's valuable knowledge, so we want to record that instance, but we want to encourage reproducers to move on and not to invest more in the paper if this is an exercise which is part of a classroom or something like that. But if they want to move forward and still reproduce a paper that has no materials, we also want to identify that case. Once they have identified a paper, the exercise is to scope the exercise. So identify how many scientific claims does the paper have, how many of those scientific claims is the reproducer going to tackle, and other characteristics of the paper. Then reproducers will move into the assessment part, where basically there will be 2 main components, and here I will take a little bit longer because I think it's the key part of the exercise. The idea is that first, reproducers will identify all the elements behind a display item, a table or a figure, and they will be asked to draw the connection between the data sources as described in the paper in a narrative way, and the specific files behind those data sources. So they might not be there in the reproduction package, but at least they can identify what the data sources are. They can then identify what the analytic data sets are, and they can also identify what the code scripts are, the code files. And we have developed a very nice tool within the platform to help reproducers basically visualize how all the pieces that are in a reproduction package come together. So once they have inputted into the platform what are the inputs and outputs of a code script, they can generate what we call a reproducibility tree. Basically, it's just a plain text representation of how all the inputs and outputs connect with a final display item. This is an example of a complete diagram, but there could be examples of incomplete diagrams as well. Then, when they have identified how all the pieces can connect to each other, they are well positioned to assess the reproducibility of a given display item. And we have come out with this scale from levels 1 to 10, 1 being the lowest level of reproducibility, 10 being the highest. And the idea here is that we want to build levels to allow incremental improvements later on, and these levels will increase from having nothing to having just the code, to having some of the analysis data and the code, and then having all the analysis on the data, and then being able to reproduce exactly the same results starting from analysis data, what we call computational reproducibility from analysis data, or CRA. Then the same exercise, but from raw data. So having all the cleaning code, having all the raw data, and being able to reproduce from raw data. And this scale is subjective. It might not be obvious all the time that one level is superior to the other, but I think these categories are helpful to distinguish the different scenarios and to aggregate this information later on. Another important scenario is when the data it's not accessible because it's confidential or proprietary. In that sense, when that happens, we want to still ask the reproducers to assess these the reproduction materials not in the availability of data, but in the availability of instructions. So how much instructions are out there to assess, to access the data? Is it detailed? Is it partial? And I basically assess the levels of reproducibility on the basis of availability of instructions. And in order to get computational reproducibility or CRA, they will have to prove that there's some third party, somebody not involved in the original research team that was able to reproduce this exercise. Once they have done the assessment, they can move into improving it. Or as they're doing the assessment, these are not necessarily linear all the time, but as they're doing the assessment, they can figure out that they can improve the reproduction package a little bit. And we basically have categorized different types of improvements at the paper level, at the display item levels, and also we have created a category in the platform to allow reproducers to leave a trail for future reproducers and say, hey, when I was working on this, I ran out of time, but if you're going to work on this, these are some improvements that I think would improve the current reproducibility of the paper. Things like write certain sections of the analysis in an open source software, improve the algorithm that you're using to increase the speed of computation, all sorts of improvements, adding more comments, something like that. And finally, basically when you have the machine running and you have you can get close or to exactly the same results as the as the original paper, then you can check the robustness of the results. And here we think of two types of robustness contributions. One, it could be from a user that is not so familiar with the literature that they are reviewing, and they just want to basically identify where are all the analytical choices for a given paper, or a subset of the analytical choices. And the other one, another type of contribution, would be to justify the appropriateness of a specific test. So when you want to, basically a robustness check, first of all, is going to be any possible computational choice. And the robustness, the universe of robustness checks could be pretty large, potentially infinite, actually. So we will follow here the nomenclature from Simonson et al., where basically we'll try to focus on reasonable specifications, which are sensible tests of the research question, expected to be statistically valid and non-redundant with previous tests. So basically, reproducers who are going through this exercise, they're gonna have the opportunity to either increase the size of the feasible set of reproductions, or propose reasonable new robustness checks. And this is clearly connected to the level of reproducibility, in the sense that if you cannot reproduce anything, there's nothing, the size of the feasible set is gonna be empty. If you cannot get to CRA, you're not gonna be able to check any new extensions. And levels 5 through 9, you will be able to check some, and if you have level 10, you will be able to check basically much more in the entire paper and much more. So basically that's how we have thought about computational reproducibility, and with that we have developed basically the Social Science Reproduction Platform. That's what I wanted to spend the last 15 minutes showing you a little bit. So Social Science Reproduction Platform, it's already in public and it's in beta version. You can go to that URL and you can get started, join with your account, ORCID or Google, and once you're in there, you're gonna have your set of reproductions. So these are gonna be all the reproductions that you have worked or are working on, and the way you will start from zero is that you will record a candidate paper. This I'm gonna demo this. So you will record a candidate paper here. Again, start from selection of the paper. Say that you were assigned a given paper, and you are given the title or the reference of the paper. One thing you can do is to go to Google Scholar and just put let's say that we're using this paper as a test, and once you find it, you can obtain the digital object identifier, or the DOI, which is this little number that's here. That is here. Trying to select it. Okay. And you will go here and you can paste the DOI of any given paper, and the platform will search for you all the specific metadata, and here will be the title, year of publication, authors, and publication and journal. So here you will have to check whether or not there is any reproduction package available. In this case, there is. And once there is a reproduction package available, you can first of all specify where it is, and then move on and declare the paper. if you were to say there is no reproduction package, the platform will ask you, have you contacted the authors? We have guidance of how to contact the authors, and we'll ask you to record how that interaction went. And then even if there's no reproduction package available, you can still try to reproduce it, but if you decide not to, we'll ask you to save it and then start a new exercise. But now we know that there is a reproduction package, so we'll move forward. And from this point, I'll show you one version that is completed. So here we have a version that it's completed of this reproduction, where basically here's all the information on the paper. Where is the original reproduction package? If we go to scoping, this reproducer, you just create a quick name. When do you start? When do you think you're going to finish? Some information about the paper. Then how many claims can you identify in the paper? Do you plan to investigate the entire paper? Yes or no? If no, how many claims are you going to investigate? And a summary, an optional summary of the paper, identifying the key parts. Then log in, and the reproducer is asked to log in to record where they're going to deposit their revised reproduction package. This is any added pieces that they're going to be improving upon. And identify the claims. So just provide a couple of sentences maximum describing what's the key claim of a paper, where is that claim in the paper, so in which table, what's the estimate, what other elements can help us identify that claim, and what are other alternative specifications that support that same claim. It could be in different tables too, different display items. These for as many claims as the reproducer chooses to tackle. And also they can pre-specify possible robustness checks that they will do once they get to the robustness section. Once that is done, then you can access the assessment section. And for assessment, again, this idea that first you're going to identify basically all the pieces of a reproduction package. Basically, what are the data sources as described narratively in the paper? So something like that. Where are they in the paper? Is there a file associated with it? Is that file provided? Is it cited? Do you have access to analytic data? These being the data where the final regressions or tests are going to be conducted upon, and where are they located? And these are the code scripts. So in this case, there's only one code script, which is this one. What are the inputs? What are the outputs? And with all this, then the platform will construct for you this reproduction tree. In this case, the reproduction tree it's rather small because there's just one script. But you can see right here, just looking at this, that gives you an idea that maybe here there's only access up to the analytic data, because it's pretty clear that there's no data cleaning process or anything like that. Then the platform asks you to basically describe if there's anything like a master script or a master do file or anything like that. What type of corrections did you have to do, and then describe for each display item that contains the estimates in the claims that you identify in scoping. The reproducers will be asked to describe what materials can you find by looking at the tree and looking at the package. what materials are available, can you compute the results that you pre-specified. In this case, they compute and they had exactly the same. And then you're asked to provide your subjective assessment based on this 10-point scale. In this case, the reproducer assess that this paper is reproducible up to this display item is reproducible up to the analytical data. Similar for the other display item. Then at the paper level, also reproducers can identify what good practices that follow. And here the original authors follow a standard or clear file organization, something that TIER has played an important role in promoting actually. Okay, so then you're done with assessment, and you will move to improvement. And reproducers can report improvements at the display item level and at the paper item level. In this case, a reproducer identifies some improvements for this display item, table 4. They're saying that they replicated the analysis using open source software, and they produced an R script and an annotated R Markdown file, which is pretty cool. Other improvements here, improvements there, and all these things are recorded for other reproducers to see and to form part of a more constructive conversation around this, around reproducibility. These are display item level improvements. These are paper level improvements, like using version control and other things that the reproducer did. And then again, once you have everything up and running, you can optionally move to robustness and take any of these two approaches, either where you, or both, where you add, identify the analytical choices that you can tweak at some point, and these are here. This reproducer identify the lines in the code where analytical choices were taken, and then they test a specific new specification. So they added quadratic experience controls, and in a rather free form here, reproducers can report the results of the exercise. And all this information, it's recorded and can be shared later on and discussed. That will be the entire exercise. Once reproducers are done, by default, the platform will suggest to make this exercise completely public. But if by some reason reproducers would like to have their identity protected or wait for a little bit until they make this they make their identity public, there will be an option for them to choose how much of their identity they want to reveal. So going back to the presentation, other things I wanted to highlight of the platform is that reproducers can have a space for discuss different subjective judgments or different resources that they might have behind papers. So we have a forum where there will be a discourse forum with entries per paper, but also for tips for reproducibility and things like that. And here people can discuss, hey, I'm getting this reproducibility tree, what are you getting? I found this data, or I think that this is an analytical choice and this is not. Basically, and also here, hopefully reproducers can compare reproduction exercise, and over time we aggregate those results to say something about the reproducibility first of a field in general, then as for subfields, and if there's enough reproductions for a given paper, we will say something about that given paper. Another important resource that I want to emphasize are the Acre guides. So in the platform website, here you'll find the guides, where basically there's detailed documentation around each of these stages. So around paper selection, scoping, assessment, improvements, and checking robustness, how to conclude the exercise, examples of reproduction trees, and many others. So, and all these, both the platform and the guides are open source, so people can contribute, and you can edit it directly and create a suggestion of how to, I don't know, define things in a different way, or how to add new components to this exercise and things like that. The one thing that I wanted to highlight particularly of the guides, it's that we do want to, this whole exercise that we're trying to put a strong emphasis behind a constructive exchange between original authors and reproducers, and for that we created a chapter with template language to guide a little bit of this conversation, following a paper by Nicole Jans, who keynote this symposium, and Jeremy Fries. Basically, we took those principles and we built some template language around this, where here there are some sort of like boilerplate emails saying, "Dear original author, I'm contacted you about a specific paper, and I wanted to ask certain things." Here, actually, in the presentation, I have some of the emails, and the entire emphasis is that we wanna move away from sort of like strong language, and here's some example. Unfortunately, I was not able to locate any of these materials in places where I have already looked. I will record this result in Acre. With your permission, I will also record materials that you can share with me, which would allow access for future reproducers. All this information will be recorded in the platform so people can access it later on. Please let me know if there are any issues. And also emphasizing that though your cooperation with me and any future requests would be extremely helpful, please note that you're not required to comply. So like minimizing the potential space for conflict. And we also have thought of other scenarios where things get a little bit more complicated, but there are several examples in the guides. A type of example is following up, trying to ask for some other material that the reproducer received the package, but the reproduction package, but there's some data missing, and then you can say, hey, there are some specific issues missing. You can use the reproducibility tree, for example, to say, look, I've done a significant amount of work, and I have identified that this, for example, these scripts and data is missing. Could you help me find it? And things like that. So the target audience of the Social Science Reproduction Platform, it's students doing graduate empirical courses, undergraduate students doing thesis projects. I think this we have done a pilot with an undergraduate student, and it worked out pretty well. So we think that this is a valuable exercise to do as a thesis, especially if you go through the exercise of reconstructing the raw data or reviewing in detail the raw data. And also for researchers conducting reproductions and original research. So for internal purposes, researchers can use these to track, like, how is their reproducibility tree looking, do some quality assessments, and basically keep track of their project. Some reasons to get into this, I think at the end of the day, what you get from the platform as an instructor, you get a standardized report. The student will send you a link to this, and you will just see standardized responses that you will be able to easily assess and grade to to assess the understanding of the student. Basically, it's easy to grade, it's easy to guide and oversee, it's easy to set up as an independent study or as a thesis. It reduces the duplication of requests to authors. We're going to keep track of those interactions, and the idea is to have to minimize the instances where authors are asked about the same question, about the same data, and have to repeat the responses to different audiences. And also, we think that this facilitates a constructive exchange of ideas when emailing authors, and also when discussing reproductions in the forum. And also, I think you'll get the satisfaction of contributing a public good to the scientific profession. So if you're interested, go to www.socialsciencereproduction.org. You'll get this. This is the beta version, which is available now. Version 1.0 is coming up in July. And if you're interested about using this as part of your course for the fall, for example, just send us an email, and we would love to chat more with you. Thank you.